All right, this is section 3.9, and it's titled Differentials. We're actually only going to talk about one small part from this section, though. We're going to talk about tangent line approximations of a function at a point C. This is also called linear approximation. All right, tangent line approximation is linear approximation. So as x approaches this value c, our y value approaches f of c. So we can actually use y equals f of c plus f prime of c times x minus c to get pretty darn close to our point. So what does that mean? We're going to find the tangent line approximation of f of x equals 1 plus sine of x at 0, 1, and then use a table to compare the y values just to see how close we were at that point. So to do this, we need to find f prime of 0. So we need f prime of x, which is going to be cosine of x. So I need f prime of 0. Cosine of 0 is 1. Our slope is 1. To write our tangent line approximation, we take y equals f of c, which is 1, plus f prime of c, also happens to be 1, times x minus c, which is 0. So our tangent line approximation is 1 plus 1x, or as we usually like it, x plus 1. Now we're going to plug in some numbers and see how close we were. Into my original function, if I plug in negative 0.5, I get 0.521. If I plug in negative 0.5 into my tangent line approximation, I get 0.5. If I plug in negative 0.1 to my actual function, I get 0.900. If I plug that into my tangent line approximation, I get 0.9. If I plug in negative 0.01 to my actual function, I'll get 0.990. Obviously, there were more numbers after that. If I plug it into my approximation, I get 0.99. If I plug in 0 to my actual f of x, I get 1. If I plug it into my tangent line approximation, I get 1. If I plug in 0.01 to my actual function, I get 1.010. If I plug it into my tangent line, I get 0.01. If I plug in 0.1, I get approximately 1.100. Plug it into my tangent line, I get 1.1. And if I plug in 0.5 to my actual function, I get 1.479. If I plug it into my tangent line, I get 1.5. So you can see right at 0, we are spot on. The further I get away from 0, the less accurate my tangent line approximation is, but it's still pretty darn close, which makes this very helpful for places where we can't really plug in numbers, such as finding the linear approximation for the cube root of x at x equals 8, and using it to approximate the cube root of 8.05 and the cube root of 25. So to do this, we are going to find f prime of x, which is 1/3 x to the negative 2/3. And we're going to find that slope at 8, which is 1/3 times 8 to the negative 2/3, which is actually 1/12. We're also going to need f of 8, which is just 2. Cube root of 8 is 2, because we need that for our tangent line. Our tangent line, y equals f of 8, so 2, plus our slope, which is 1/12, times x minus that x value I plugged in, which is 8. So our tangent line is 2 plus 1/12 minus 8/12, which is 2/3. Oops, I forgot my x there. So our line is y equals 1/12 x plus 4/3. And we're going to use that to approximate the cube root of 8.05. And to do that, we just say, okay, 1/12 times 8.05 plus 4/3. Now I can't actually do that in my head, but I get about 2.004. Now if I take my calculator and I say, okay, what is the actual cube root of 8.05? 2.004. We are pretty darn close. Now let's say I approximate the cube root of 25. I get 1/12 times 25 plus 4/3. I type that in my calculator, I get about 3.417. Well, let's see here. The cube root of 25 is actually 2.924. We're not actually that close. So the further I got away from 8 as my input, the further off my approximations became.